Hello and welcome to Study Digital.
Before we begin, I would like to read out a small quote by René Descartes, which says, "It is not enough to have a good mind. The main thing is to use it well." So in the last session of Coordinate Geometry Part 1, we covered some topics. They were what are axes, origin and quadrants, the coordinates of a point in a plane, coordinates of points on the axis, to plot the points of given coordinates, as well as we solved the exercise 7.1. In today's session of Coordinate Geometry Part 2, we'll be discussing the topics further of this chapter, which includes lines parallel to the x-axis, lines parallel to the y-axis, graph of linear equations, the graph of a linear equation in general form, and we'll be solving the practice set 7.2 of your textbooks. So let us first have a look at what do we mean by lines parallel to the x-axis. So on a graph paper, plot the following points. So we take a graph paper, we draw our x-axis and y-axis, and we know that x-axis and y-axis are perpendicular to each other, that is, they intersect each other at an angle of 90 degrees, and the point of intersection is nothing but 0, or it is also known as the origin. Then the origin divides the x-axis into two parts. On the right of the origin we have all the positive numbers, and on the left of the origin we have all the negative numbers on the x-axis. The origin divides the y-axis into two parts. That is, above the origin we have all the positive numbers on the y-axis, and below the origin we have all the negative numbers on the y-axis. So after drawing the axis and plotting the points on the axis, now we first plot the point A, which is given to us with coordinates 5, 4. So the x coordinate is 5 and the y coordinate is 4. So we take the first coordinate as x, and we see where on the x-axis we have number 5, which is here. Then the y coordinate is given to be 4. So we consider on y-axis we try to plot where do we have the point 4, which is here. Now the intersection of these two points will be the location of our point A. So our A point lies here. Next we have been given point B with x coordinate as 2 and y coordinate as 4. So on the x-axis we try to locate where is 2, that is here. And on the y-axis we try to locate where is 4, which is here. And again the intersection of these two points will be the location of point B. Next let us consider point E with coordinates 0, 4. So the x coordinate is 0 and the y coordinate is 4. So on the x-axis we locate 0 and on the y-axis we locate 4, which is here, which means this point lies on the y-axis. Similarly, we plot point C, D and F. So we locate the position of the point C with x coordinate as -2 and y coordinate as 4, which is on the x-axis we locate where is -2, that is here. And on the y-axis we locate number 4, which is here. Again, the intersection of these two points will be the location of point C. For point D, we have been given coordinates -4, 4. So the x coordinate is -4, which lies here on the x-axis, and the y coordinate is 4, which lies here on the y-axis. Again, the intersection of these two points will be the location of point D. And our f coordinate lastly has coordinates as 3, 4. So we locate on the x-axis point 3, which is here. On the y-axis we locate number 4, which is here. And the intersection of these two points will be the location of point F. Now, observe the coordinates of the given points. do you notice that all the y coordinates of all the points are equal? Yes, if you all observe that all the y coordinates of these points given here, they are same. All the y coordinates are 4. All the points are collinear, that is, lying in the same straight line. So if you all observe here, all these points lie in the same straight line. So when all the points lie in the same straight line, they are said to be collinear points. Now, they're asking to which axis is this line parallel. So after plotting all these points, we drew this line. Now can you all tell me to which axis is this line parallel? We can call this line as line DA. So yes, this line is parallel to the x-axis. If you all observe closely, it is parallel to the x-axis. So line DA is parallel to x-axis. The y-coordinate of every point on line DA is 4. It is constant. Therefore, line DA is described by the equation y equals to 4. If the y-coordinate of any point is 4, it will be on the line DA. So as we know, we have all the y-coordinates as 4 here of all the given points. Therefore, if the y-coordinate of any point is 4, it will be on the line DA. The equation of the line parallel to the x-axis at a distance of 4 units from the x-axis is y equals to 4. So the equation of the line parallel to the x-axis. So this line is parallel to the x-axis and it is at a distance of 4 units from the x-axis. How do we measure the distance? So from x-axis, if we look here, it is at a distance of 4 units, from 4 to 0 or from 0 to 4. So we know the distance between line DA and the x-axis is 4 units. Therefore, the equation of this line DA is y equals to 4. Now, something to note here. If B is greater than 0, what is B? B is nothing but a y coordinate. So, if it is greater than 0, we draw the line y equals to 4 or y equals to B through the point 0, B. It will be above the x-axis and parallel to it. So, if the y-coordinate is greater than 0, so we observe here, in this case our y-coordinate was 4. Since it is greater than 0, it will be above the x-axis. This is our x-axis and the point is 4, the y-coordinate is 4. So it will be above the x-axis and obviously it is parallel to the x-axis. Similarly, if B is less than 0, then the line y equals to B will be below x-axis and parallel to it. Now, in another case, if we assume our y coordinate to be minus 4, since it is less than 0, it will be below the x-axis, but again it will be parallel to the x-axis, right? So if y equals to b, here if b is greater than 0, it will be above the x-axis and parallel to the x-axis, and if it is less than 0, it will be below the x-axis and still be parallel to the x-axis. The equation of a line parallel to the x-axis is in the form y equals to b. So the equation of any line in its general form which is parallel to the x-axis is of the form y equals to b. Now let us understand lines parallel to the y-axis. So we saw about lines parallel to x-axis. Now we'll have a look at lines parallel to the y-axis. So again, on a graph paper, we are required to plot the following points. So what do we do first? On the graph, we draw our x and y axis, which is perpendicular to each other. We plot the points on the axis and then we plot these points. So point P is given to be minus 4, 3. So x coordinate is minus 4 and y coordinate is 3. So on the x-axis, we see where is minus 4. It is here. And on y-axis, we see where is 3, which is here. So the intersection of these two points will be the location of our point P. So our point P lies here. Again, the point Q is with coordinates minus 4, 0. So on x-axis, we locate where is minus 4, which is here. On y-axis, we locate where is 0, which is here. So this means this point Q lies on the x-axis, right? Now our next point is given to be minus 4, 1. So the x coordinate is minus 4. So on the x-axis we have minus 4 here. The y coordinate is 1. On the y-axis we have 1 here. So the location of point R will be the intersection of these two coordinates, which is here, right? Now again similarly we plot point S with coordinates x as minus 4 and y as minus 2. So we get S here. The coordinates of point T is minus 4, 2. So we get T here. And the coordinates of point U is minus 4, 3. So the x coordinate is minus 4 and the y coordinate is minus 3 here. So the intersection of these two points will be the location of point U. So after plotting all these points, we draw a line through these points. We have to draw a line which passes through all these points. So we get this line PS here. Alright? Now observe the coordinates of the points. Again, if you observe here, what do you notice? We notice that all the x coordinates of the points are same. So all the x coordinates, if you all observe here, are same. It is constant. Are the points collinear? Yes, the points are collinear. What do we mean by points being collinear? It means all these points lie on the same straight line. It has to be a straight line and all the points have to be on the same straight line. Only then the points are said to be collinear. Now, to which axis is this line parallel? So what do you all observe? To which axis is this line parallel? Yes, right. This line is parallel to the y-axis. So this is our y-axis and this is a line PS. This line PS is parallel to the y-axis. Alright? The x-coordinate of every point on line PS is minus 4. It is constant. Therefore, the line PS can be described by the equation x equals to minus 4. Every point whose x-coordinate is minus 4 lies on the line PS. The equation of the line parallel to y-axis at a distance of 4 units and to the left of y-axis is y equals to minus 4. So any point with x-coordinate as minus 4 will lie on this axis. And since this line PS and since this line PS is parallel to the y-axis, the equation of this line will be y equals to minus 4. Right? Now, one important thing to note here. If we draw the line x equals to A is nothing but the x coordinate. So if we draw the line x equals to A parallel to the y-axis passing through the point A, 0, and if A is greater than 0, then the line will be to the right of the y-axis. If A is less than 0, then the line will be to the left of the y-axis. Again, if our x coordinate is greater than 0, so it will be above the y-axis, and if it is less than 0, it will be below the y-axis. But in both the cases, or if the coordinates are greater than 0, then the line will be on the, if it's greater than 0, the line will be on the right of x-axis, and if it is less than 0, it will be on the left of x-axis. And in both the cases, the line will be parallel to the y-axis. So in our case, the coordinate was less than 0, that is minus 4. The x coordinate was minus 4. So therefore, the line is on the left of the origin or the left of the y-axis. And if it was greater than 0, if we assume it to be 3, it would be on the right of the origin or on the right of the y-axis, and in both the cases it would be parallel to the y-axis. The equation of a line parallel to the y-axis is the form of x equal to a. So the general form of any line parallel to the y-axis is x equals to a, right? Now, something to remember. The y-coordinate of every point on the x-axis is 0. Therefore, every point whose y-axis or y-coordinate is 0 is on the x-axis. Therefore, the equation of x-axis is y equals to 0. Next, the x-coordinate of every point on y-axis is 0. So, the x-coordinate of every point on y-axis is 0. What happens then? Every point whose x-coordinate is 0 is on the y-axis. Therefore, the equation of y-axis is x equals to 0. So, we have two more general forms here. The equation of x-axis is y equals to 0 and the equation of y-axis is x equals to 0. Now let us understand what do we mean by graph of linear equations. So we've been given this example here which says draw the graphs of the equations x equals to 2 and y equals to minus 3. So we've been given two equations. The first one is x equals to 2 and the second one is y equals to minus 3. So let us understand how do we go about it. On a graph paper, draw the x-axis and y-axis. So on a graph paper, we draw our x-axis and y-axis. We mark the intersection of the two axes, that is our origin. We plot the points on the x-axis and y-axis respectively. Then, since it is given that x equals to 2, draw a line on the right of y-axis at a distance of 2 units from it and parallel to it. Now we've been given that x is equals to 2, which means that the x coordinate is 2. So on the x-axis we locate where is 2, which is here. So we draw a line passing through this point and this line will be parallel to the y-axis. Next, we've been given y equals to minus 3. Therefore, we draw a line below x-axis at a distance of 3 units from it and parallel to it. So we've been given y equals to minus 3. So on the y-axis we locate where is minus 3, which is here. So we draw a line passing through this point and this line will be parallel to the x-axis. It will be at a distance of 3 units from the x-axis. These lines parallel to the two axes are the graphs of these equations. So these two lines that we drew are the graphs of the equation. This is the graph of the equation x equals to 2 and this is the graph of the equation y equals to minus 3. Write the coordinates of point P, the point of intersection of these two lines. So these two lines intersect each other at a certain point. So if you all observe closely, this intersects here. So the intersection point of these two lines is P and this P has coordinates 2, which will be the x coordinate, and minus 3, which will be the y coordinate. So yes, our two lines are here and the intersection of these two lines is point P with coordinates x as 2 and y as minus 3. So that's how we draw a graph of the linear equation. Now let us understand the graph of a linear equation in general form. So we've been given an example here which says 2x minus y plus 1 equals to 0 is a linear equation in two variables in general form. So what do you mean by two variables? We have been given two variables in this equation. So one variable is x and the other variable is y. Let us draw the graph of this equation. So we are required to draw a graph of this given equation. So let us understand how do we go about it. So the equation 2x minus y plus 1 equals to 0 means y equals to 2x plus 1. So if we take all on the right hand side, it becomes y equals to 2x plus 1, right? Let us assume some values of x and find the corresponding values of y. Now you all know, in order to plot any point or any line on a graph, we need to know its x and y coordinates. So since we've not been given any value here, let us find out. So for that, we will assume some values of x, and with the help of those assumed values, we will find out the values of y. So for example, if x equals to 0, so here we assume x to be 0, then substituting this value of x in the equation, we get y equals to 1. So if we consider this equation, y is equals to 2x plus 1, and if we consider the value of x to be 0, so if we add 0 here in place of x, which will give us y equals to 2 into 0 plus 1. Therefore, 2 into 0 gives us 0 plus 1. So the value of y will be y equals to 1, right? So when we assume the value of x to be 0, we get the value of y to be 1. Now similarly, let us find the values of y when 0, 1, 2, half and minus 2 are some values of x, and write these values in the table in the form of ordered pairs. Ordered pairs means in the form of x and y coordinates, right? So we assume the values of x to be 0, 1, 2, half and minus 2. By adding all these values or by substituting all these values of x in this equation, we will find the values of y. So let us consider the first one. X equals to 1. So when x equals to 1, we substitute this value of x in the equation y equals to 2x plus 1. So y equals to 2 into 1 plus 1. Therefore, we get the value of y equals to 3. So when x equals to 1, y equals to 3. Now, second, when the value of x we assume to be half. So when the value of x is half, we substitute this half in the equation y equals to 2x plus 1. So in place of x, we write the value of x that we assumed, which is half. So when we solve this, we get the value of y to be 2. So when x equals to half, y is equals to 2. We write it down in the table. Next, we assume the value of x to be 2. So when x is equals to 2, we substitute this value in the equation y equals to 2x plus 1. So in place of x, we write the assumed value of x, that is 2. Therefore, we get the value of y as 5. So when x is equals to 2, y is equals to 5. And lastly, we assume the value of x to be minus 2. So when x is minus 2, we get the value of y as minus 3. So in the equation 2x plus 1, we write minus 2 in place of x. So therefore, when x is equals to minus 2, y is equals to minus 3. So now by assuming all these values of x, we found all the values of y by substituting the value of x in this equation. Now we write as per the questions in the form of ordered pair. So we wrote all these values in the form of x and y coordinates. Now let us draw the graphs of this equation. So now let us plot these points. Let us verify that these points are collinear. Let us draw that line. This line is the graph of the equation 2x minus y plus 1 equals to 0. So these are the points that we got, our x and y coordinates. Let us plot this on the graph. So we draw our x and y axis, and this is perpendicular to each other, that is, it intersects at point O or the origin O with coordinates 0, 0 at an angle of 90 degrees. And we name these lines as y and y dash and x dash. So we have our two axes, x-axis and y-axis. Let us plot the first point. Our x coordinate is 0 and y coordinate is 1. So on the x-axis we locate 0 and on the y-axis we locate 1. So the intersection of the 2 points will be the location of our first point, which is here. Next, our x coordinate is 1 and y coordinate is 3. So on the x-axis we locate 1 and on the y-axis we locate 3 here. So the intersection of the 2 points will be the location of our next point, with x coordinate as 1 and y coordinate as 3. Next we have x coordinate as 2 and y coordinate as 5. So on the x-axis we locate 2 and on the y-axis we locate 5, which is here. So the intersection of the 2 points will be the location of this point, with x coordinate as 2 and y coordinate as 3, right? Next we have x coordinate as half and y coordinate as 2. So half is nothing but 0.5. So we locate 0.5 on x-axis, which is here, and on y-axis we have to locate 2, which is here. So the intersection of the 2 points will be the location of this point. So we get this point here. And lastly, our x coordinate is -2 and y coordinate is -3. So we locate on the x-axis -2, that is here, and on the y-axis we locate -3, which is here. So the intersection of these 2 points will be the location of this point, which is here, with x coordinate as -2 and y coordinate as -3. Now we have to draw a line which passes through all these points. So we draw this line and we have to make sure it passes through all these points. Now, can you all tell me, are these points collinear? Yes, these points are collinear since they lie on the same straight line. So this line is the graph of the equation 2x minus y plus 1 equals to 0. So we write it here, right? So that's how we draw the graph of a given equation.
So that's it for this video. I will catch you in the next one. Happy learning!